Okay, today's lesson is on how to prepare our data for analysis. So the reason that we learn this is because once you create your surveys in Qualtrics and send them out, you'll get your data back and you can choose to receive your data as an SPSS file. You'll then open your SPSS file just like we open the Santa Fe file in class, and you can make some manual adjustments to fix it or to edit it and to prepare all of that data to be analyzed. It won't come in exactly perfect, so in some cases you'll need to address the missing data. In some cases you'll need to recode it so that if they used a qualitative response or maybe a category, you can transform that into a number that we can then use to create frequencies or to even do some statistical inference. So today's lesson is how to get our data ready to be analyzed. The reason that this is such a big deal is because the data doesn't come perfectly ready. So imagine Walmart and all of the scanner data that they have available. They collect information on every single scan that comes through their system. Like if you were to just purchase apples, there's little stickers on your apples with a 4-digit code, and every single scan that they put in, every time they look at those apples, they have how much money they've earned, they have how many apples need to be ordered in order to replace those apples, down to the point that they have different stickers for red apples and green apples. So the more green apples you buy, the more green apples they replace. They know exactly how many green versus red apples need to be ordered and replaced. They've also collected information about you, the customer, the employee that scanned it, the products, the time of day, the store location, what types of products are purchased together or bundled together. They have all of this information on the computer. And sometimes little pieces are missing. So in order to use it, they need to be able to fill it all in or to convert it so that it can be analyzed. Data preparation is just essential in converting raw data into usable coded data. So it's taking all of that scanner data and converting it so that it can be used based on its codes. It can be used to create a statistical analysis. It also plays a role in assessing and controlling the integrity of the data and making sure that the data is of high quality by detecting any potential response or non-response biases, which we'll talk about, some errors created along the way, especially in the coding or in the data entry. For today's lesson, I want you to think of more than just a Qualtrics survey. You may even think of people that are standing outside actually filling in paper surveys and needing to put that into a system in order to be analyzed. So here's all of the steps that we need to think about in terms of data preparation analysis. Today's class, we're focusing on these top pieces. We're looking for error detection in validation, editing, coding, data entry, data tabulation, and data analysis. The next part is the analysis piece, which is when we can do a descriptive analysis, univariate and bivariate analysis, and multivariate analysis. Then we start to interpret our data. Today's class is just that top part. We're looking at the validation of the data, how we're going to edit it and how to code it, how to enter it into the system. Remember, we could do manual entry or we could upload it. Data tabulation and data analysis. That's where we're going to start today. Next class, we'll break it down into the different ways that we'll analyze the data and how to interpret it. So this was just that chart broken in half to show you how the two classes are separate. Today we're doing chapter 10. What you're looking at right now is for chapter 11. So let's talk about the data preparation process. We're going to talk about each of these components. The data validation, how to edit and code it, data entry, and data tabulation. Data validation is the process of determining to the extent possible whether the interviews or observations were correctly conducted and free of bias. So we want to know if our surveys, our interviews, our observations, whatever it is that we're doing to collect data, were they done correctly? A big one to look out for here is if using an interview or if you're doing a person-administered survey. So if there is someone from your research team that's conducting this research by talking to people and filling in blanks, there's this idea of curb stoning, which is when rather than actually having respondents fill out the survey, the interviewer fills them out themselves. This would be equivalent to for your class projects, one person in your group filling out all 120 surveys. It's called curb stoning because it comes from interviewers standing on the curb and filling out interviews rather than actually talking to people and having them fill out the surveys themselves or with them. And in Qualtrics, I can look for this kind of thing. I can look to see if the same computer was used to fill out every single survey. So we have ways to prevent this when it comes to online surveys, but if it's a paper survey, it's still a little difficult to prevent this sort of thing. We want to make sure that it was all conducted correctly. There's a couple areas that we focus on: fraud, screening, the procedure, the completeness, and the courtesy of the researcher. So one way to look at all of this is to contact a small set of the respondents. So if you are paying someone to go out and actually conduct interviews and have these surveys done in person, you can always get contact information for the respondents and give maybe 10 of them a call and make sure that their survey was done correctly. So for the fraud piece, we would want to find out if the person was actually interviewed, or was there curb stoning involved? Was this person actually part of the study, or did the interviewer do the entire thing themselves? For the screening component, we'd want to find out if the respondents were screened the way that they were supposed to according to our screener questions. Remember, we might have some pre-selected criteria that only UK students be considered, or only females be considered. Whatever the screener questions are, we want to make sure that those responses that we're getting back are actually following that screener procedure. It's kind of hard on telephone interviews to ensure that the person responding is over 18 or meets with that criteria. So it's good to potentially call back or send an email and find out if the respondent actually did meet that criteria. Was the procedure done correctly? Was it scientific? Was it in the correct setting? Was it within the correct time frame you were supposed to have? So was the actual procedure of taking the survey done correctly? Were all of the questions answered? If they weren't all answered, was it because the respondent chose not to answer, or is it because the interviewer got lazy? So was the survey as complete as it should have been? And then was the interviewer or was the survey experience courteous, and was it respectful to the respondent? Did they feel like they could remain neutral if they wanted to? Did they feel like everyone was friendly and helpful? Did they feel like the interviewer or the survey itself had a nice appearance? It was easy to understand. Did they enjoy the survey experience? Next is the editing. So here are some areas of editing concern. Editing is the process of checking the data for mistakes. So instead of thinking of editing as changing it necessarily, think of editing as checking it for mistakes. And those mistakes could have been made by the interviewer, by the respondent. They could have been made during transferring the data from paper to manual entry into SPSS, or maybe even from uploading from Qualtrics to SPSS. So editing is the total idea of checking the data for mistakes. We want to make sure that we asked the proper questions. And sometimes, unfortunately, you don't realize until you're looking at the data that the responses you have don't actually answer the questions that you were hoping to answer. This is why we spend quite a bit of time on this in class, and I look over all of your questions and all of your items. We want to make sure that the data we're getting actually answers the objectives and that they were completed. We want to make sure that the questions were recorded accurately. We could fill in missing data. We can handle any skipped questions at this point. If we have skipped questions, you'll see in SPSS that we need to go back and address it before we can do any analysis. So we need to make sure that all of our recorded responses are handled accurately. We need to make sure that the screener questions were done correctly. And the beginning questions that determine if someone is qualified or even able to complete the survey. We need to make sure that we have that screener information so that we know that it's okay for us to be using all of this data. And then we want to make sure to look at any open-ended questions, any kind of qualitative open-ended answers at the end of the survey. We can probably put these into categories and maybe even do a small bit of analysis on these, calculate some percentages of people that responded a particular way. Even though it's open-ended, we could still come up with a coding pattern like we did for the prom example and start to code them too. So coding is the process of grouping and assigning value to various responses from the survey instrument. And we can code quantitative and qualitative data. When we're talking about coding quantitative data, so let's think of just a regular Likert scale. You may say, please state the extent to which you agree with the following statement: I like dogs. Strongly disagree, disagree, neither disagree or agree, agree, or strongly agree. So you've got 5 responses there. Coding is the process of assigning each of those values with a number, each of those responses with a number. So it would be a number 1 to 5. On a Likert scale, we typically code from 1 to 5 or 1 to 7. We said we don't like to go a whole lot higher than 7. But if we only are assigning categories for gender, we would have male and female. So we would have a 0 or a 1. We could still assign a value to them, 0 and 1. We can't say that 1 is better than a 0 in that case, but we can still assign a number to it, which will help us do some analysis later on, even if it's just frequencies. And we can assign codes to qualitative data too. So for the prom example, we ended up with about 10 different categories that males were interested in, 10 different categories that females were interested in, or that females mentioned. We could assign a code starting at 0, going up to however many we had, 9, 12, 15. We could assign a code to each of them and then look for patterns. That process is a 4-step process of developing these response codes. We generate a list of the potential responses and we assign the values. We consolidate the similar answers. We consolidate the similar responses. So think back to the prom example. We generated the list of potential responses on the board, and then we consolidate responses. For example, if someone said, I liked the flowers, and someone else said the flowers were nice, we could consolidate those to both be about flowers. Even though people wrote out slightly different answers about their prom experience and used different wording, both of those get at the idea of the flowers. So we would consolidate those into one category, flowers. And then we assign a numerical value. It's best to start with 0, and when possible, you want to use 2 digits. So you would use 0, 0, 0, 1, 0, 2, 0, 3, and we do that in case we go higher than 10, it stays consistent with 2 digits. And in general, whether you're doing qualitative or quantitative, you want to keep negative type responses with lower numbers and positive responses with higher numbers. So if you were recoding the responses for I like dogs, we would have strongly disagree be on the lower end and strongly agree be on the higher end. So it may be 0 is strongly disagree and 4 is strongly agree. or in that case, you could go 1 is strongly disagree and 5 is strongly agree. You just want to make sure that your numbers start with the negative or disagreement on the lower end and the positive or higher agreement on the upper end. It'll make it easier to interpret later. And then every single answer, every single response must be coded. For qualitative, that can take quite a while. Data entry includes the tasks of putting the data into the software package. We're using SPSS, so it would be the process of getting the data into SPSS so that we can ultimately manipulate it and then transform that raw data into information that we can use in our analysis. And again, we talked about in the lab, we can do this 2 ways. We can either manually enter the data. So if you had paper surveys, you could go in and actually type in the data, or you can just upload the information. But either way, you can still have some errors. The software will sometimes help you. There will be error edit routines in which the software can help detect errors for you. If you're only supposed to have responses ranging from, say, 1 to 5, it may be able to go back and tell you, uh-oh, there's an 8 here, something's wrong, you need to look at it, stuff like that. It may point out missing data. So a lot of times the software has built-in features that will help you kind of edit any sort of mistakes that were made and make sure you change them to fit into the parameters that you wanted. It's also nice to scan the actual data that was entered, and this means just look at it, not scan it as in scan it on the printer, but scan it as in look at it. So when you have that huge sheet open with just all the raw data, take a look, and if you know that the entire sheet should be just responses from 0 to 7, and you look and one cell has an 8-digit number in it, then you know something was wrong, and you can see that quickly just by scanning. I always do this in the beginning. Once all my data is entered, the first thing I do is just scroll around kind of randomly and look to see if there's any responses that stick out as being really weird. And occasionally it just happens. Occasionally the way the data gets transferred over, a number gets sent kind of goofy, or it's got decimal points with it, or just things happen. So it's nice to just take a second, look around, kind of scroll around in the data and make sure that everything looks the way it's supposed to look. And we can also produce a data column list procedure for the entered data where we look at it by column to check for missing data. So just take a look at this one right here. And again, this is just kind of scanning the data to see if there's any huge errors. It doesn't look like there are any numbers that stick out like a sore thumb as being incorrect. It looks like all of our responses are 1 to 7s, which is good, but we do have quite a bit of missing data. So we now know we would need to address missing data in this process. All right, the only other thing we're going to talk about today is tabulation, and this is the very first thing that we would be doing in terms of analysis. We could do this with quantitative data, and we could do it with qualitative data if it had been coded. So think of your prom example. That would be our qualitative data that we've talked about. If we coded each of those categories, let's say flowers and venue and dress shopping and photos, and we assigned each of them a value, 0, 0, 0, 1, 0, 2, we could calculate the percentages of how many people responded to each of those categories in the same way that we can calculate the percentages of people that responded to a particular scale point on a survey. For a one-way tabulation, we are talking about the categories of a single variable. The next step I'll do is show you one so that you can actually see what to do. And in the lab, I will show you how to actually do it in SPSS. And the reason we do this is to calculate just some summary statistics or some percentages. Essentially, we are counting the number of observations that are classified into a category. So we are counting up the number of observations, the number of people that responded strongly disagree, or the percentage of people that responded agree. And we can either do this by looking at one variable at a time or more than one variable at a time. So let's look first at a one-way. These are all of the different Mexican restaurants. We have Superior Grill, Mamacitas, I think that's Ninfa's. I'm not sure how you would say it. We have Moe's, Santa Fe Grill, Jose's, Papacitas, and then a couple of other categories. Remember, we want to make sure everyone has something they can respond to. So the other categories were other, none, and don't remember. If you look at the frequency, that is telling you the actual count of people that listed that restaurant as the restaurant that they ate at. So 99 people said Superior Grill, 74 people said Mamacitas, 110 said Ninfa's, 47 said Moe's, 38 said Santa Fe Grill, and I think you get the rest of that on down. So the frequency is the count of people. Now this is out of, if you look at the total, 493 total responses. So the percent column is showing the percentage of that frequency out of the 493 total. So for Superior Grill, 99 people said that they ate there, and 99 people is 20% of the 493. 74 people said they ate at Mamacitas, which is 15% of the 493 total. 110 ate at Ninfa's, which is 22% of the 493. 47 people ate at Moe's, which is 9.5% of that 493. So we can look at it as either a raw count, the frequency, or we can look at it as a percentage of how many of our total respondents ate there. So that's a one-way frequency based on more like qualitative responses or categories. Here's another one-way frequency, and this one is showing the individual categories of responses for a scale. And this scale was measuring the frequency of patronizing Santa Fe Grill. How frequently do you eat at Santa Fe Grill? And the responses available were very infrequently, somewhat infrequently, occasionally, somewhat frequently, or very frequently. So when the person took the survey, those were the scale points that they saw. And then once the data was put into SPSS, it was coded 1 to 5. And again, that's keeping in line with the more negative, very infrequently as the lower number, and frequently the more positive response as the higher number. And we can now see for that one variable, how frequently someone eats at Santa Fe Grill, 49 responded that they ate there very infrequently. This time we had 427 responses, so that was 11.5%. We could look to see how many people ate there very frequently. The actual count was 90, and that 90 is 21.1% of that total amount, 427. And this time you can see that there was missing data. 27 people did not respond to this item. So we had 400 responses, but 27 did not respond, so our total is 427. The percentage that we are seeing is the percent of the total. Now that was all looking at one variable. We can also do what's called a crosstab. So we're moving from a one-way to a crosstab. The difference is that a crosstab allows us to look at two variables at a time. We can even go more than two. In this class, we'll typically stick with two. And the reason we do this is to determine if certain variables differ when compared among their smaller subgroups. For a lot of projects, this is kind of where it ends. This is as far as people want to go. In our projects, we will go much further. But in terms of just companies doing quick research and trying to get quick counts of information, this is all that they want to do, is figure out quick differences between groups. So, for example, we could look at how males and females, with gender being one variable, differs on their scale responses or scale categories. So let's look at an example of this. Here we look at two variables. The respondents' desire to eat balanced, nutritious meals and their gender. So if it was still a 1 to 7 scale, with a 1 being that they do not eat balanced, nutritious meals, or it's not important to them, and a 7 being that they strongly agree that eating balanced, nutritious meals is important to them. When we look at this, we can see that the balanced, nutritious meals variable is going to indicate our rows here. It's on the left side, and our gender is our columns. So if we look all the way across, no one responded with a 1. No one said that eating a balanced meal was completely not important to them at all. But a couple people did say only a 2. We followed across 12 males and 6 females for a total of 18 responses to that second category, which was disagree. 73 people responded to a 3, which was 39 males and 34 females. Then we had 91 people put down a 4, which was 61 males and 30 females. All the way up to strongly agree that eating a balanced, nutritious meal is really important to them. No males, but 12 females, for a total of 12 respondents. So we're now seeing the breakdown of not just the importance of eating a balanced, nutritious meal, but also breaking it down by gender. So we can see the total for each one just as if it was a one-way tabulation, but we've also done a crosstab by separating it by gender also. So in general, the cool thing about these is you can quickly look and see that females tend to be a little more balanced across their answers. There's 34 threes, 34s, 35s, 29 6s. It's pretty balanced across all the responses. Males, however, tend to get more positive towards the higher end of the scale. Starts out with 12 and 39, then it moves to 61, 89, 63. So even though there's more females, only females respond to strongly agree, in general, that 4, 5, and 6 are taken over by the males. There are more males in the study. If you look, there's 264 males and 141 females. There are more males. But it's still interesting to see that the females have a pretty set pattern in the 30s, evenly distributed across the responses, and the males definitely skew towards eating a balanced, nutritious meal. That is the end of today's lecture. Here's the things that we talked about. Now all you need to do is complete the activity, and I will see you next class. Thanks so much.